Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. I'd like to talk about hypothesis tests and when to use those. I want to go through an example. I think it'll be easier to explain. I recently was looking at some data about the racial inequities that were being discussed at the University of Iowa in the football program. So, for an example, the black players, there were 32 of them that finished their career and 45 of them that did not finish their career. They either transferred or dropped out of school. And this is a time period between 2009 and 2015. For the white and non-black players, 43 finished their career and 31 did not finish. So if you look at the percentages, for the black players, 41.6% finished and 58.1% for the white or non-black players finished. So if that percentage was something like 49% versus 51%, we might conclude that the data is close enough, it's within the margin of error or within the natural variation, that we might not think anything of it. But at some point, as those numbers start to differ from maybe it drops to 48 to 52, still maybe in the margin of error. How about 45 to 55? Now we start seeing maybe there's a difference here. And when you get down to 42 and 58, it seems like that's a pretty big difference in those groups. So what hypothesis tests do is they allow us to check our data versus how many samples we have and how far apart the difference between those two numbers are to see if it's statistically valid. And this can be done in two ways. We can either look at it as a p-value, which is what is the likelihood to get these kind of outcomes if those two groups are exactly the same. So if we assume that there's a 50% dropout rate, how likely would you have gotten 42 versus 58? Probably be very unlikely, and so that p-value would be very, very small. And we would say this can't just be due to odds or chance. So it's probably due to something else. If the numbers were much closer, then the p-value would be very high, saying this is a very likely outcome. You could get 49 and 51 if 50% is kind of the overall average. Another method is to use confidence intervals to put some kind of range around the results. In the article, and I'll link to that in the show notes, I look at the confidence interval for the difference. So there's a 16% difference in those two groups. And the confidence interval says with 95% confidence, the real difference is somewhere between 0 and 32%. Right, that's pretty widespread, and that's why we need to take these things into account, because with this few samples, about 150 student athletes, we would expect, a certain range of those values. And if you had more data, that confidence interval would get smaller because you'd be more confident in what the real results are. So this use of the p-values and confidence intervals can help us really understand, is this a significant difference in groups, or is this noise or random variation? And that's a really important element of Six Sigma. So if this topic is new to you or you'd like to learn more about it, you can check out Greenbelt training courses. I won't say that shows up in every Greenbelt class, but it's pretty typical. So in conclusion, the difference between the black student athletes and the white and non-black student athletes, there was a statistical difference between those two groups. And so that gives some evidence that maybe there's something going on with how the athletes are fitting into the culture and the program, or how they're being treated. And so that's more to come in that story, but just wanted to share an example and how hypothesis tests can fit into this. Okay, I hope that was helpful to you. Thanks. LeanSixSigmaDefinition.com has a list of glossary items about popular process improvement terms, along with a history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ohno, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit LeanSixSigmaDefinition.com.